This presentation will discuss the best management practices for pink rot of potato. A handout for this presentation and others can be found at the Miller Research website. Pythium leak and pink rot are two diseases that can be found in potatoes both at harvest and in storage. The photo on the left shows Pythium leak, and this is characterized by what appears to be a wet area. The lenticels and the eyes may have a black appearance, and this is very similar to what you might see with pink rot, which is shown here on the right. One difference between these two photos is that in the pink rot photo, the infections occurred at the point of the stolon attachment. So in this case, the pink rot pathogen has infected the potato plant, and the underground stems or stolon have then just grown by direct contact out into the potato tuber. In this case, with Pythium leak on the left, the leak pathogen is infected through either an eye or a lenticel. And so they're very different in the way that they may look in the field. When you cut these open, the differences become even greater, easier to see. With Pythium leak, there'll be a gray to a dark brown to black area, and this tissue can be quite soft. When you squeeze it, water will actually leak out of the potato, giving it its characteristic name. Pink rot is different. The infected tissue does not become soft. It has almost a cooked texture to it, and it will be an off-white or a cream-colored appearance. And up here is where the potato has been infected. And there's a pretty distinct line between the infected and the healthy tissue below. There are many different things that growers can do to manage pink rot. And these 9 options that we have listed here are all important. It's critical that growers take an integrated approach. There's not much that growers may be able to do to select the fields they're going to use. However, crop rotation becomes very important. The shorter the rotation, the more pressure of pink rot you're going to have in your fields. pH is also an important player. We found that lower pH, meaning 6, around the area of 6 or lower, can increase infection by the pink rot pathogen. So doing things like adding lime to increase the pH of the soil will help reduce that pressure. Growers can plant less susceptible varieties, and we'll show some examples in a moment. Irrigation management is also critical, as are the use of fungicides, and we'll discuss that in this presentation. Growers can avoid disease-favorable conditions at harvest. The use of post-harvest fungicides can be done also if there is disease in the field prior to harvest, and that will protect potatoes going into storage, and we'll mention that for just a moment. You can also grade out infected tubers going into storage, and that's what's shown in this photo down here in the bottom right. And once they're in storage, if you can get the pulp temperature to 55 degrees or lower, as soon as you can do that, that will delay the development of pink rot. This chart shows a relationship between pH and the infection level of Phytophthora, the pathogen. This was work that was done by Jared Benson, a graduate student of Brad Geary at BYU, and was published at the American Journal of Potato Research. And they were able to grow potatoes in a hydroponic solution and adjust the pH of that solution. And they found when they went from a pH of 8 down to 7, 6, or 5, the quantity of DNA recovered from the potato plants increased. Or to say this the other way around, as the pH was increased, the infectivity of the pH of the pink rot pathogen decreased. A similar relationship was found by the addition of calcium, and these two of course are related. As the available calcium increases in the soil, the pH is going to increase, and so as you see this range here, as the amount of calcium in that hydroponic solution was increased, the infectivity of the pink rot pathogen decreased. Cultivar susceptibility is also something that growers do have some ability to change. We know that narcotas are highly susceptible, as shown in here. This is natural infection in the field, and what was a close second was Clearwater. Now, statistically speaking, Burbank and Payette were also similar to those, but Narcota and Clearwater have kind of raised near the top of those varieties that we usually use in southern Idaho, which are susceptible. Teton and Bannock, along with Ranger, are more resistant, and so at least they showed less disease under similar growing situations. Irrigation management is also important. We did a series of trials under natural infection using Narcota, where in a given week we would put on the same amount of water on 3 different treatments. The difference is some treatments received it all at one time, whereas others received half the amount twice. and others would receive a third of the amount 3 times. But in a given week, they all had the same amount of water. And this did vary a little bit through the season, depending on the ET. But at the end of the year, the amount of pink rot that we had under the 1X or the 2X irrigation regimes was significantly higher than what we saw with irrigating 3 times a week with less water. When you also look at the yield here, we had significantly higher yield where we are irrigated 3 times with a third of the water. Now this may seem somewhat intuitive, but the bottom line is irrigating more frequently with less water decreases the pink rot pressure. Now there are many fungicides that are available for pink rot control, and I have put these in groups according to their mode of action. These groups are numbered that are defined by the Fungicide Resistance Action Committee. So group 4, we have mefanoxam or metalaxyl-based products. You may be familiar with those as Ridamel Gold. There's also Ultra Flourish, Metastar, and Xylar FC. And these have been very effective in controlling pink rot. They're systemic. They can be absorbed by the plant and redistributed down to the tubers. And they've been found to be very good as in-furrow applications. However, there are some conditions that might negate that in-furrow application. We've found in southern Idaho, under our conditions, that foliar applications have been more consistent. These are typically applied when you want to start when the largest tubers are dime size with a repeat application 2 weeks later. There have been some resistance to the mefanoxam and metalaxyl products. And in some areas of southern Idaho, especially in the eastern side of the state, that resistance was widespread going back in the 2000s. We found that the one answer to that is to use phosphorus acids. And these are a different mode of action. They're a different group. And some examples of these include Fostrol, Resist 57, Phytocide, and there are others out there that are labeled for that. These have been very effective. There are some issues with that, which we'll discuss. There's a new product, oxythiopiperalin, which is combined with mefanoxam and is sold as Orondis Gold. It can only be used in furrow right now. I mean, this is a very, very effective product against late blight. But we have a lot of products that work against late blight. So I see one great benefit from this is its activity against pink rot. So this is a new mode of action. It's a group 49, and it has been combined with mefanoxam. 2 others that we've done work with here in southern Idaho include cyazofamid, which is labeled as Ranman, and ethoboxam, which is labeled as Illumin. They are also in different groups. They have not been as consistent as those that we've seen in the first three groups, but they do show some activity, and some growers have reported using these with good results. But we feel that they may not be as consistent performers as some of the others. This is a slide showing in-field results where we had about a 50% of the population was resistant to mefanoxam and 50% was sensitive, and those are based on isolations that we made from control tubers that were not treated with anything by the end of the season. And in this case, each column represents a timing. So we were planting on May 4th, and that was the in-furrow application. We had dime-sized tubers around July 5th. Then this column represents 2 weeks after that, 2 weeks later, and 2 weeks later. So in the untreated check, this row showing the applications that were made at those timings, nothing was applied, and we had a little over 8% pink rot. Using Ridamel Gold in furrow gave me approximately 50% reduction. So this is even in the presence of sensitive and resistant isolates. When I used a foliar application, I had very, very similar results in this Ridamel Gold Copper. When I use Metastar, and I will point out Metastar is actually metalaxyl, whereas Ridamel Gold and Ridamel Gold Copper are mefanoxam, and there is a slight difference between those. It was not statistically different from the check, but it did have it was also statistically similar to the mefanoxam products. What worked the best was using Phosphite, which is a phosphorus acid or a phosphite, at 10 pints per acre 3 times, starting at dime-sized tubers and repeated on a 2-week interval. And that gave us the lowest amount of disease. There have been issues or concerns about Phosphite causing phytotoxicity, which it does fairly regularly. So we also looked at a reduced rate, which was 7.5 pints 4 times. So applications made at dime-sized tubers and then followed on a 2-week schedule. It was statistically significant to the 10-pint approach, but it had a little bit more disease. In fact, we found that statistically it also was similar to the mefanoxam approach. One of the problems with phosphorus acid, as I mentioned, is phytotoxicity. This is a picture of some of that phyto which can occur. These were photos provided by Dr. Andy Robinson. He did a lot of tests with this and found that the addition of some adjuvants can even make this phytotoxicity worse. And so this is something that we don't see very often, but it is a cause for concern for those who do. That caused us to do some trials looking at using the same total amount of active ingredient, but using lower rates of the season. So we have an untreated check where we had 14% incidence of pink rot. Here we had phosphoral at 10 pints per acre, and we made 3 applications, starting when the largest tubers were dime sized and then repeated on a 14-day interval. And that gave us almost complete control of pink rot in the field. And these were russet norcotas with natural infection. And we took that same amount of active ingredient, in essence 30 pints, we reduced it to a 5 pint per acre application, and we made 6 applications, this time starting at dime-sized tuber but going every 7 days. And by doing that, we had a result which was statistically significant to using a 10 pint per acre 3 times. Now, early on, we didn't follow this because we felt many growers weren't making 6 applications. We felt 3 was more in line with what they were currently doing. But because of the phytotoxicity, this is something that could be done and that would help reduce that. We also tried a 5 pint per acre rate on a 2-week schedule instead of a 7-day schedule. And this was initiated when tubers were dime size. And what happened was, by the time we got to that 6th application, basically the potato crop was done with the norcotas. They were dead vines, and so we weren't able to make that final application. Now, whether that was the issue or whether the fact that we were applying the phosphorus later in the season, regardless, it did not give us the same level of protection as what we got with 10 pints per acre 3 times. But it was still effective. We're often asked if we can do a rescue treatment with pink rot. For instance, maybe there's a field where no applications were made because the concern was that I don't think I'm going to get disease. Then say come the end of July or early August, out doing some digs in the field, you find you do have some pink rot in the field. Would it be worth the time to make a fungicide application? And the short answer is no. This is a trial that we did where we waited until we found pink rot in the field, and that's what we call our rescue approach with both a phos acid, in this case, I believe it was phosphoral, and then Ridimil Gold Bravo. We found this, I believe it was July 29th. So the very next day we went out on July 30th, and we made an application, and then we repeated on a 7-day schedule. We came back August 6th and August 13th with both the phos acid and the Ridimil Gold, and at the end of the season, that did not give us any protection whatsoever against pink rot. Now, if you compare, and this was a very high pressure situation. We were talking at the end of the season, we had over 20% pink rot by natural infection. These were russet norcotas, and the field was treated. It was overwatered in a way to promote disease. When we used Ridimil Gold Bravo on time, meaning when the largest tubers were dime size, which was for us was June 21st this year, and then 2 weeks later on July 3rd, we had over a 50% reduction in disease. So, basically, it drive home the point. If you're going to use these fungicides to protect yourself against pink rot, you need to use them preventatively and not as a rescue. As a rescue treatment, they do not work. Wanted to show some data from Orondis Gold. This is some work that we did in 2018, again on norcota with natural infection, and we had a little over 6% infection in the untreated check this year. Where we used Orondis Gold in furrow, it dropped that down below 1%. When we had Orondis Gold in furrow with Ridimil Gold Bravo, one Foliar Ridimil Gold Bravo, it dropped it even further. Statistically, they were the same. But this approach, the combination was more effective than 2 applications of Ridimil Gold Bravo. One made it dime-sized tuber, and one again at row closure. It was significantly more pink rot than the in furrow followed by the dime-size approach. So this is a product that will be effective and will help in managing pink rot. We've been asked lately if phosphites are not working as well as expected, and this is an observation that's come the last couple of years as growers have used them and felt they're not working as good as we first saw. So one of the first questions was, is resistance developing to the phosphites? And the short answer to that is no. We are not seeing resistance develop in the pink rot pathogen population. So that would bring us to some other questions. Is irrigation interfering with product uptake? Or is the timing of our application optimal? And that's what we set out to try in a series of experiments. Some work that was done out of Canada by Geifu Wong-Pruski showed that when you made an application of phosphites, that there was this time that it took the plant to uptake the active ingredient. So on this graph, this is showing the parts per million of phosphite that's translocated into the leaf. So when you make your application, of course, right at time 0, there isn't any there. Then 6 hours later, you've got up to about 50 parts per million. You wait to 24, you're up to 100. In fact, if you wait up to 52 hours, you've crossed 150 parts per million. So this led to the suggestion that perhaps if you're going to use a phosphite, you need to wait like almost 48 hours if you want to get the full benefit from the application. Now that would be a deal killer for us here in the Pacific Northwest. We can't wait 48 hours to shut off the water, especially when it's hot. So we wanted to ask, how important is this time between application and irrigation? The experiment that we set up looked something like this. We had a trial that we put down here next to where the pivot would start, and then the pivot was turned on a 48-hour revolution, and we would go out and spray certain plots there right as the pivot was started. We would also spray some 24 hours before the pivot was going to cross the trial. And we had different treatments here also. Some programs we sprayed when the plants were at full emergence. Some we started at dime-sized tubers, about a ½ inch in diameter, and others were started at row closure. We had some plots that were also treated 12 hours before the pivot would cross the trial, and some that were treated at 6 hours. We didn't get much disease in the field, so we took the potatoes into the lab, and this was done in conjunction with Dr. Nora Olson and her crew at the Kimberly Potato Storage Research Center, and we challenged these with the pink rot pathogen. And you can do this when you're working with something like mefanoxam or phosphorus acids, because the active ingredient is translocated in the tubers. In 2019, we found that if there was a 6-hour interval between when we sprayed and when the irrigation went across, we did have a significant reduction, but it wasn't as effective as if we waited 12, 24, or 48. In 2020, the results were somewhat similar. The only difference was the 6-hour interval was not effective compared to the untreated check. So the take-home message from both of these is that if you're going to wait, if you're able to wait 12 hours, and we think you can do this even under hot conditions. If let's say you're making 3 applications, those 3 times during the season, if you can say, I've got to get my water so I can give myself 12 hours between when I spray and when I water, you're going to have the most effective use of the product. You don't need to wait 24 or 48 hours, and this was substantiated on 2 different years. And so, but if you go ahead and you irrigate, or say you make your application and you irrigate right away, you are going to lose some efficacy of the phosphite, even to the point where perhaps it doesn't work at all. And we don't want growers to be in that situation. We think this could have explained why in 2021 some growers felt the phosphites weren't working well because it was so hot, and growers felt they were behind on water. I know one consultant told me that there wasn't any waiting. They'd spray and then turn the pivot on right away. And in that case, it may interfere with the phosphate application on those potatoes that were just treated. How important is timing when the program starts? Well, again, we did these challenge assays, and we found that if we treat at full emergence, we're not getting any better protection than if we go at dime-sized tubers. It looked like row closure was a little better in 2019. Statistically, it was the same as dime-sized tubers. In 2020, we had more effective control with the program starting at row closure compared to those at dime-sized emergence. Now, we had done this trial also in 2018, and we had some natural infection. It wasn't very high, but under that year, we didn't see any efficacy with the emergence applications. And so some takeaway message from this is that going at full emergence makes no sense. It's not a timing that we're used to doing sprays anyway. It's no better than doing it dime size and row closure. So we feel that we thought this might be better, but it looks like it is not. Now, dime size is one that a lot of the research has supported through the years. What we expected to find is that the row closure wouldn't work as well because you're starting a little bit later in time. But if you're looking at disease incidence, it's going to start late in the season. These were challenged at harvest. The row closure application worked just fine. So, and I do want to emphasize, this is for phosphites. We're not saying that this would be the same for a mefanoxam-based product. That may be different. In fact, a lot of the research there shows that you've got to go at dime-sized tubers. And I'll be honest, starting at row closure makes me a little nervous with the phosphites too, but the data that we're seeing shows that it should be similarly effective as using starting at dime size. So in summary, we don't think we have resistance to the phosphites. Is irrigation interfering with product uptake? It could. If you are irrigating less than 12 hours between your application of phosphite and the irrigation, that is possible. What's the optimal timing? Well, emergence gave no benefit over going at dime size, and so we think that that's probably where we still ought to be. You can start at row closure though, and that would coincide with other applications that you may be making to manage, say, early blight brown spot and also white mold. Avoiding disease favorable conditions at harvest is also important. We know that wounding can have a big effect on pink rot potatoes, as can the pulp temperature. This trial was done by Shane Clayson, who was a graduate student at the University of Idaho when I was there, and he took potatoes that had some that were adjusted of a pulp temperature of 70 and some at 60 Fahrenheit, and then some were wounded. And by wounded we mean they were rolled into a cement mixer that didn't have any baffles in it. And so these aren't causing these great big gashes. There's a little bit of shatter bruise, some micro fractures on those potato tubers. At 70 degrees, the difference between wounded and non-wounded was not great, but there was a difference. When those potatoes were dropped down to 60 degrees and wounded, there was a huge difference. And so just dropping the temperature from 70 to 60 with the pulp temperature, that caused a significant reduction in tubers that were wounded, but the reduction is even greater in non-wounded tubers, to the point where we're not getting much pink rot at all. So at harvest, if you can harvest cooler and avoid wounds, it's going to minimize the amount of pink rot that would develop going into storage. Questions often asked, well, if I have a good foliar program, do I need to worry about the post-harvest application? Because the post-harvest data show that you get almost complete control. But I think you have to look at these very differently. The first question you need to ask yourself is, was the field program sufficient? There are many reasons that might explain why a foliar program of, say, either a mefenoxam-based product or phosphites, or even, let's say, you're using Orondis Gold, maybe it wasn't 100% effective. There could be environmental issues, application problems. Maybe you're on a short rotation, so the fungicides aren't going to give you 100% disease control. Perhaps you've over-irrigated. I know no one likes to admit that, but it does happen. Under these conditions, maybe you still have pink rot when it comes time to harvest. So if disease is present in the field, then you may want to engage a post-harvest program. But I don't think you want to say, well, I'm going to use the post-harvest, I'm not going to use a foliar program, because that's going to increase the pressure, that's the amount of disease you'd have to deal with going into storage to begin with. Even with a really good program, you may have some pink rot develop in the field. Now, the reason that we look at using a post-harvest application to begin with is you have these tubers which are infected, and these are highlighted by the yellow arrows here. And research done by North Dakota State, and Neil Goodmistad when he was there, showed that as these potatoes come in contact with healthy potatoes, they can actually contaminate those. And so then these potatoes now become at risk to developing pink rot once they get into storage. And this is where we developed the use of post-harvest fungicides, particularly phosphorus acid. And this was work that was done at the University of Idaho with myself and Nora Olson. Something that we just played around with on our own to see would it work, and found, in fact, Lynn Waddell, Nora's technician, found that she came up with the rate of 12.8 fluid ounces per ton. And this was trying to estimate, what would we normally use in the field that would work, and how could we translate that to a ton of potato tubers and going in storage. This rate has been found to be very effective. If we go higher than that, we don't seem to get any better control. And if we go lower than that, sometimes we do see a drop in control. So it's important to try to shoot for this rate of 12.8 fluid ounces per ton. And as far as carrier volume, we want to use about 1/2 gallon of water per ton of tubers. In the arid conditions of the Pacific Northwest, this is shown to be very effective. In other areas where, say, they're more humid and potatoes are maybe they're wet and moist coming out of the ground, this could be a problem, and I don't want to shy away from that. We hesitate to put water on potatoes as they go into storage. We don't, because that could cause a soft rot problem, which would be a lot worse. But if you're dealing with in dry conditions and the potatoes are dry, making this kind of application can be very effective. In some cases, growers have these applications set up so where the potatoes are almost dry before they have gotten to the piler. We did some trials, Nora Olson and I, looking at 8 different potato varieties. And to walk through this graph, the row of yellow column bars in the back, or columns, represents potatoes that did not receive a field program. They did not receive a post-harvest program. They were challenged with the pink rot pathogen after harvest, and this is the level of disease that developed. So for most of these varieties, here we have Burbank, Ranger, Norcota, line 278, Alturas, Umatilla, Teton, and Clearwater. They were all very similar. Dakota showed a significant level of resistance. In fact, we only got half the infection with that variety as we did with the others. Now, the blue columns in front of that represent those same potatoes, only they received the foliar program of Phosphite. So in this case, it was Resist 57. We made applications of 10 pint per acre 3 times, starting at dime-sized tubers. And we had a statistically significant drop with Burbank. There was a fair amount of disease. The reduction in Ranger wasn't statistical. With Norcota, though, it was. We had a big reduction with just the field program alone, and this is with challenging these potatoes as they're getting ready to go into storage. And when Nora and I were working with trying to develop this application, most of our work was done with Norcota because of its susceptibility to pink rot. And so it's encouraging to see that with this variety, we're getting the biggest reduction with our post-harvest spray. The effect with Alturas was not significant, but it was with Umatilla, also with Teton and Clearwater. So, some of these varieties are responding more to that post-harvest treatment than others. Over here with Dakota, which had less to begin with, that foliar program cut it really, really low, almost not quite to zero, but close to it. And when we take those same potatoes, so these orange columns here represent potatoes that did not receive any treatment in the field and only received a post-harvest treatment about an hour after they were exposed to the pink rot pathogen. And we had no disease. And that was true also for those that had received the foliar program. So again, I've had people look at this and say, well, gosh, I shouldn't even worry about the foliar program. I'm just going to do the post-harvest spray. But the problem is, this is only dealing with disease that might develop in storage, or potatoes that have become exposed to the pink rot pathogen during the harvest process. The post-harvest treatment is not going to help you keep pink rot out in the field. And so we recommend that growers approach this using a field-based program. Then if there's some reason that program doesn't work, you could add the post-harvest program to provide additional protection. The post-harvest application with phosphorus acid. In this case, we were using Phostrol. And we would challenge potatoes or inoculate them with the pink rot pathogen and spray immediately, and that was time 0. We also did this at 1, 2, 4, and 6 hours later. And with the Phosphite or the Phostrol, we had very good control of pink rot all the way up to 2 hours after the potatoes were inoculated. We even had a good reduction at 4 and 6 hours. And we didn't carry it on beyond that to see how long it would go. But the encouraging news is if your potatoes are being exposed to the pink rot pathogen during the harvest operation, whether that be being lifted from the ground from the windrower or being thrown in the truck, going into an even flow bin, there's going to be some time maybe before it reaches that post-harvest spray. And our data would show that you have up to 2 hours, you're still going to get really good control with this Phosphite application. We also looked at hydrogen peroxide, peroxyacetic acid, and in this case we're using oxidate. And when that application was made at time 0, so right after inoculation, we had about a 50% reduction in disease. But when we were an hour later or 2 hours later, we didn't have any efficacy with that. Now, this becomes important because the post-harvest treatment is a pain. It's difficult to do, and we've often been asked, well, it'd be better if I could just load the potatoes into the storage and get them in there, get the door shut, then run something through the ventilation system. Now, unfortunately, that kind of approach does not work well for the phosphites. It's a very heavy product, and in efforts that have been made to make an aerosol out of it, it tends to condense when it hits corners It just does not move very well. Now, you can make an aerosol or a humidification application of hydrogen peroxide, peroxyacetic acid. However, think about this time effect. If you wait a certain amount of time from exposure to when your treatment, you're not going to have good effect. And so this is why that post-harvest spray as they're going into storage is so important, rather than waiting till later. So to summarize what we've talked about today, I'm not going to go through all of these again. I just want to highlight some of the new research that we had. When we talk about proper irrigation management, remember with the phosphites, it would be great to ensure there's a 12-hour interval between when we make that application, when we irrigate, and with the phosphites at least. And this, I'm not saying this would be true for any other product. It appears you can start at row closure, which might be about a 2-week delay from dime-sized tuber, and you're still going to have a good effect. However, I still think going at dime size is a good approach, and it would be beneficial for managing pink rot. With that, I'd like to thank the sponsors for much of this research, and that has been the Northwest Potato Research Consortium. And thank you for listening to the presentation today.